Welcome to NIOS Studio. This program is based on Senior Secondary Chemistry course. In the previous program, we have discussed about liquefaction of gases. I am Dr. Alka Mehrotra. We will continue the lesson 5, the gaseous and liquid state. During this part of program, we will be discussing the characteristic of liquid state, compressibility and diffusion. Now, let us first discuss about the arrangement of molecules. You can see here like how the molecules are arranged in solid, liquid and gases. Now, the molecules are very close to each other in solid. When it is like that, it means we can say the shape and the volume is fixed in solid, and they are all based on the intermolecular force of attraction. The intermolecular force of attraction is maximum in solid than in liquid, and in gases it is least. Then the space, solids, there is no intermolecular force of space between them, or we can say the negligible is there, while in liquid it is more than solid but lesser than gases. So, because of that we can come to the conclusion of the various property of solid, liquid and gases. Like solid have a definite shape, definite volume, while in liquid they have definite volume but not definite shape, but in gases they do not have any definite volume or the definite gases. Now, characteristic of liquid state. Now, we are going to study basically in this part liquid state. So, let us discuss about the characteristic. As you have seen, molecules are held together by intermolecular force of attraction. Intermolecular forces in liquids are stronger than gases but lesser than solids. Very little space between them, hence molecule in liquids are closer than gases. Under normal conditions, liquids are more denser than gases and less denser than solid. They have fixed volume and take the shape of the container. Like suppose if you are putting water in the glass, you will say that the shape of water is like that, because the shape wherever we are taking, it will take the shape of the container, but the volume will always fix. Suppose if you are taking 5 ml in the beaker, or 5 ml in the test tube, or 5 ml in the cup, or 5 ml on the saucer, it will remain the same volume. Now, molecules can slip so they can flow. That is very important point, because the fluidity is there in the liquid. They can always flow from up to down, higher to lower level. Now, liquids cannot be compressed or very little compressible. So, now what is the compressibility? Because all the properties you have already done in the junior classes, but compressibility now, it is really very important. Compressibility of a substance is its ability to be squeezed when a force is applied on it. Liquids are largely incompressible. Like in previous videos, you have noticed when we were talking about gases are highly compressible. Now, liquids are largely incompressible. It is because there is very little empty space between them and between the molecules. In contrast, the gases are highly compressible because of the large empty spaces between their molecules. Now, let us do one activity to make you more clear. When we discussed about gas, if you remember, I showed you again with this syringe only, and we have taken like this, and you have noticed that it was highly compressible. Now, what are we going to do now? We will check with the liquid. We have taken the water and we will fill the water in this. You can see the water is over here. Now, what are we going to do? This is stationary. Now, I am going to put my finger over here and I am going to press it down very forcefully, pushing the plunge inside. And if you also do, you will find, so you have to apply a lot of pressure, and still you will find that it is not going down. So, why? Because they are incompressible. And why are they incompressible? Because the molecular gap, the gap between the molecules are not that much. very lesser. So, we can just apply a little bit and then we will find we are failed to compress it. So, this is how we can explain the compressibility in the liquids. Now, let us discuss about diffusion. Diffusion is the process of spreading of a substance from the region of higher concentration to the region of lower concentration. This was seen in gaseous state also, and in gases it is highly, the diffusion is more. And the best example was gas we have discussed about the agarbatti. If the agarbatti or incense stick is burnt in one corner, you can smell it in the other corner. Now, let us check about the liquid also. Now, diffusion occurs in liquid because the molecules of both the liquids are moving and help in the diffusion process. So, what can we say about the solid then? It means solid, the diffusion will be very negligible. Now, this also I will show with the help of the activity. So, now you can see we are going to put one drop of ink in the water. Okay. Now, see how it is going to diffuse very slowly. It is getting diffused, and the reason for this is that the intermolecular gaps are there, space is there. So, the particles of the ink are getting diffused in between the gap between the water molecules, and slowly you will find that the whole water will become the ink color. Maybe you have taken blue color or black color, it will become like that. I will show you like this. First, I have taken the water, as you have already noticed, plain water. We put a drop of ink and slowly it was getting diffused. A drop gradually dissolves into the glass of water, and now you can see it is getting diffused and the water is becoming the color of the ink. So, we can show the diffusion by this activity. I hope this is very clear to you. So, now let us recap what we have done, that liquids have definite volume but no definite shape. These are the very, very important properties and are almost incompressible, that you have noticed, and they can diffuse, that also you have seen. Thank you.